China just built a $10 billion canal that moves more cargo than the Panama Canal, and most of the world had no idea it was even being built. 134 miles of waterway, carved through mountains and solid rock, completed in 28 months. The Panama Canal took 10 years. You heard that right. China beat one of the greatest engineering achievements in human history by a factor of 3. This is the story of how China looked at a problem that had quietly strangled its western provinces for decades and decided to engineer its way out of it entirely. And to understand why this canal exists, you first need to understand the hidden economic trap that made it absolutely necessary: the landlocked penalty. Imagine you run a factory in Chengdu, Sichuan. Your warehouse is stacked floor to ceiling with aluminum ingots, coal bricks, and chemical drums, millions of tons of product that the world wants to buy. Your workers showed up, your machines ran all night, everything is ready to ship. But here is where your problem starts. You are over 1,000 miles from the nearest major port. Every single ton of product you made has to travel by road or rail just to reach the coast before it even touches a shipping container. And that journey costs you not a little. A ton of cargo moved by truck costs roughly 5 to 6 times more per mile than the same ton moved by barge on water. You are paying that premium on everything, every day, on every shipment, whether prices are good or bad, whether your margins are thick or razor thin. Multiply that across Sichuan, Guizhou, and Yunnan, combined 3 provinces producing coal, steel, aluminium, and chemicals in quantities that rival entire nations. And what you get is not just inefficiency. What you get is a structural ceiling quietly pressing down on 95 million people who work just as hard as anyone on China's coast, but consistently earn less, export less, and grow slower. Economists have a name for it: the landlocked penalty. And in Western China, it had been compounding silently for decades. Coastal factories in Guangdong and Jiangsu pay almost nothing in transport surcharges. They load directly at port. Their logistics cost is a rounding error. Yours is a line item that bleeds your business every single quarter. The playing field was never level, and nobody was fixing it. But the problem ran even deeper than the money. Western China was not poor in resources. Guizhou alone sits on some of the largest coal and aluminium reserves in Asia. Yunnan produces phosphate chemicals that global agriculture depends on. Sichuan has the industrial base of a mid-sized European country. The raw materials were there, the workforce was there, the factories were there. What wasn't there, what had never been there, was a cheap, reliable way to move everything those provinces produced to the markets that needed it. That gap had a price tag. It just never appeared on any government balance sheet. And Beijing had finally decided it was time to pay it off once and for all. The decision that changed everything. China's infrastructure planners had been staring at this problem for years. They had run the numbers, they had studied the maps, and they had tried the obvious fixes first. Rail expansion was already underway across the western provinces, but rail has a ceiling. It is expensive per ton, it is capacity constrained, and it was already under pressure from passenger traffic competing for the same tracks. Road freight was holding the system together through sheer volume, but it was the most expensive option of all, and it was scaling in the wrong direction as fuel costs climbed. And the one existing waterway option routing cargo through. The Li River in Guangxi was too shallow, too narrow, and too ecologically fragile to handle heavy industrial tonnage at any serious scale. So planners proposed something that on paper looked almost delusional. Build a brand new canal, from scratch, through the hilly terrain of Guangxi Province. 134 miles long, 3 megalocks, 90 bridges, 13 million cubic yards of rock and earth removed. All of it connecting the Xijing River system, the gateway to western China's interior, directly to the Beibu Gulf coast and the South China Sea beyond. The last time a nation attempted something like this from a blank slate, it was the United States finishing what France had abandoned in Panama. That project killed thousands of workers, took a decade, and nearly broke 2 countries before it was done. China looked at that historical benchmark and gave its engineers 28 months. Construction on the Pinglu Canal broke ground in August 22. But before you can understand what they built, you need to understand the terrain they chose to build it through, because the land itself fought back every step of the way, carving through the earth. Picture the southern edge of the Yunnan Guizhou Plateau. This is not the flat cooperative delta land that engineers dream about. This is broken, stubborn terrain, karst rock formations jutting out of the earth, river valleys cutting unpredictably through the hills. Elevation changes that would have stopped most planners cold before they even unrolled the blueprints. This is the landscape China chose to put a canal through. The Pinglu Canal runs from Nanning, the capital of Guangxi Province, southwest toward the Beibu Gulf coast at Guizhou. 134 miles of artificial waterway threading through hills, valleys, and solid rock. And from the very first engineering decision, the team made clear they were not here to take the easy route, because there was no easy route. The first challenge was the terrain itself. Engineers didn't spend months searching for a gentler path around the hills. They went straight through them. Over 13 million cubic yards of earth and rock were excavated to carve the canal's channel enough material to fill over 5,000 Olympic swimming pools. You heard that right. 5,000 pools worth of rock and soil pulled out of the ground and moved just to make room for the water. The channel they carved is 83 feet wide at the surface and 18 feet deep, built to a standard that allows fully loaded river-class cargo vessels to pass through at international scale. 2 vessels can move in opposite directions simultaneously without slowing down. Then came the bridge problem. The canal's path crossed dozens of existing roads, highways, and local routes that couldn't simply be closed for 3 years. So rather than rerouting traffic, China built over 90 bridges directly over the canal, many of them constructed simultaneously while the channel was still being dug beneath them. Infrastructure layered on top of infrastructure, being built at the same time, in the same corridor. And then there was water. A canal 134 miles long needs a reliable, manageable water supply across its entire length regardless of season. The Pinglu Canal draws from the Xizang River network through a system of automated flow controls that balance water levels in real time, adjusting to rainfall, cargo traffic, and lock cycles simultaneously, without human operators manually intervening at every point. But the true engineering centerpiece of the entire project wasn't the channel, or the bridges, or even the water system. It was the locks. And what China built inside them had never been done anywhere on Earth before. The locks that broke every record. Picture yourself standing at the edge of the third lock on the Pinglu Canal. You are close enough to feel the air shift as the gate moves. In front of you is a 3,000-ton cargo barge fully loaded, sitting low in the water, carrying enough steel to build a small skyscraper. And ahead of it, a pair of lock gates, the height of a 6-story building, are sealed shut. On your side of those gates, the water sits at one level. On the other side, it is several feet higher. The lock is the machine that solves that problem. It is, at its core, a water elevator, a sealed chamber that fills or drains to lift or lower a vessel between 2 different elevations. Without locks, a canal through hilly terrain is just a ditch that ships fall into. The Pinglu Canal has 3 of them, and the third one, the one closest to the coast, just became the largest water-saving ship lock ever constructed on Earth. Here is why that matters. Every time a traditional lock cycles lifting or lowering a vessel, it consumes water. That water drains to the lower level and is gone. On a canal designed to handle 95 million tons of cargo per year, that water loss is not a minor inconvenience. It is an existential threat to the canal's ability to operate. You cannot run a waterway at full capacity if you are draining your water supply with every single ship that passes through. Water-saving locks solve this by capturing a portion of that water in side chambers during each cycle, then pumping it back up to refill the next one. The third lock on the Pinglu Canal does this at a recovery rate of over 60% per cycle, meaning for every 10 units of water used, 6 come back. That is the highest recovery rate of any lock structure ever built, anywhere on the planet. You heard that right. The gates themselves are fully automated, coordinated by a centralized digital control system that manages the timing of all 3 locks simultaneously, sequencing vessel movements to maximize throughput and eliminate the bottlenecks that traditionally make locks the slowest point on any canal. At full operational capacity, These 3 locks can process enough vessel movements to carry 95 million ton of cargo annually. That is a number that would have seemed fictional for an inland waterway that didn't exist 4 years ago. But none of this would mean anything if it took 20 years to build. The real story, the part that made engineers around the world stop and stare, was how fast China actually did it. 28 months. Let's put the timeline in perspective, because the numbers alone don't fully capture how absurd this is. The Panama Canal took 10 years to build. The Suez Canal took 10 years. The Panama Canal expansion, completed in 2016, took 9 years. These are the global benchmarks. These are the projects that textbooks point to when they describe what major waterway construction actually demands in time, money, and human effort. The Pinglu Canal broke ground in August 22. The first commercial cargo barge moved through it in December 24. 28 months. For 134 miles of canal, 3 record-breaking locks, over 90 bridges, automated water management systems, and 13 million cubic yards of excavation. So how did they actually do it? The first answer is parallelism. China didn't build the canal from one end to the other like laying a garden hose. It divided the entire project into multiple simultaneous construction zones, with different contractor teams working independently on different sections at the same time. While one crew was blasting rock near Nanning, another was pouring lock foundations near Guizhou, and another was installing bridge decks over a channel that hadn't even been fully dug yet. The second answer is prefabrication. Lock gate components, bridge structural elements, and water control systems were manufactured off-site in parallel with the excavation work delivered to the canal ready to install, not ready to begin fabricating. This collapsed the on-site construction window in a way that sequential building never could. The third answer is scale of mobilization. At peak construction, over 10,000 workers were active across the project simultaneously. Coordinating that many people across that many parallel work streams without the whole thing collapsing into chaos is itself an organizational achievement that deserves more attention than it gets. But here's the part that makes engineers in other countries genuinely uncomfortable. This speed came from a system that doesn't have to ask permission at every turn. Permits, environmental review, land acquisition, utility, relocation. All of it was handled through a single centralized project authority that cut through the interagency delays that routinely add years to infrastructure timelines everywhere else in the world. And that is exactly where the story gets complicated. The ripple effect. Go back to that factory in Chengdu for a moment. The one with the warehouse full of aluminium ingots and chemical drums and coal bricks, sitting 1,000 miles from the nearest port. Everything that was true about your situation at the start of this story is still true except for one thing. There is now a water highway out. The economics of what that means are not subtle. Inland waterway transport in China costs roughly 1/5 of what road freight costs per ton per mile. Not half, not 2/3, 1/5. For a ton of coal or aluminium traveling from Guizhou's mines to an export terminal on the Beibu Gulf, routing through the Pinglu Canal doesn't just trim your logistics bill, it restructures your entire cost model. The landlocked penalty that has been compounding against Western China's competitiveness for decades doesn't disappear overnight, but for the first time, there is a credible route around it, and the industries that understand this are already moving. Within 18 months of the canal's opening, logistic zones and industrial parks were already under construction along its banks. Steel processors, chemical storage terminals, aluminium smelter logistics hubs. These aren't speculative developments built on hope. They are built to receive cargo that has always existed but never had an efficient way out. The canal doesn't create Western China's industrial output, it unlocks it. But the transformation doesn't stop at the canal's edge. Follow the water south to where it meets the Beibu Gulf coast, to the ports of Qinzhou, Fangchenggang, and Beihai. These have spent decades as second-tier ports, permanently overshadowed by the giants of Guangzhou and Shenzhen. The Pinglu Canal changes their entire identity. With a direct water connection to Western China's industrial heartland feeding them cargo that previously had no viable route to the coast, the Beibu Gulf ports are being rebuilt as serious international shipping hubs, and their coastal competitors cannot replicate the inland supply chain that is now feeding them. Then there is the layer, that turns a domestic logistics story into something far larger. The Beibu Gulf sits directly across the water from Vietnam. Beyond it lies the entire ASEAN manufacturing and consumption corridor, 600 million people, some of the fastest growing economies on Earth, and a regional trade network that Western China has never had direct water access to until now. Combined with the Belt and Road rail links already running through Yunnan into Laos and beyond, China's western interior is being stitched into Southeast Asian trade in a way that was structurally impossible 5 years ago. The canal delivered the economic payoff it promised, but not everyone who lived along its path got to share in it. The cost nobody advertises. Every map of the Pinglu Canal looks clean. A smooth blue line cutting through green terrain from Nanning to the coast. Neat, precise, inevitable looking, the way all infrastructure looks after it's built, and the mess has been cleared away. What the map doesn't show you is the village that used to sit at kilometer 47. Somewhere along that 134-mile construction corridor in Guangxi, families lived on land their grandparents had farmed and their grandparents before them. Fishermen who knew every bend of the river by feel. Farmers who had worked the same soil for 4 generations. When the Pinglu Canal project was approved and the boundaries were drawn, tens of thousands of households found themselves inside the construction zone, and they were told they needed to leave. China's resettlement program is not nothing. Displaced families receive financial compensation. They are moved into newly constructed housing in nearby towns. The government does not simply bulldoze a village and walk away. By the standards of 20th century infrastructure displacement, the dam projects that submerged entire counties with minimal warning and minimal recourse, the Pinglu Canal's resettlement process was organized, relatively resourced. But here is the truth that compensation packages cannot fix. You cannot pay someone for the thing that made a place home. The fisherman gets a check. He does not get his river back. The farmer gets an apartment. She does not get her soil back. The community that formed across generations in a specific valley does not reassemble itself in a resettlement block just because the buildings are new. This is the ledger that never appears in the project's official economic analysis, and it is a ledger that every major infrastructure project this century carries, whether it admits it or not. But the displaced families weren't the only ones raising uncomfortable questions about what had been built. The questions science can't answer yet. Guangxi is not a simple landscape. It is one of China's most biologically intricate provinces, a tangle of karst river systems, seasonal wetlands, and freshwater corridors that took millions of years to reach the delicate equilibrium you find there today. The waterways threading through it are home to species found nowhere else on Earth, including critically endangered freshwater fish populations in the Pearl River system that have survived in these specific channels since before recorded history. Then came 134 miles of new artificial waterway cutting directly across those systems in 28 months. Environmental scientists raised concerns during the review process, not whether the canal should exist, but whether the speed of its approval allowed anyone to fully understand what a channel of this scale would do to groundwater flows, river sediment patterns, and fish migration corridors over the next 50 years. The honest answer, right now, is that nobody fully knows. The canal is too new, the monitoring data is too thin, and some of the consequences that worry scientists' most invasive species migrating between previously separated water systems. Disruption of the seasonal flood pulses that entire ecosystems are calibrated around play out over decades, not months. This is not unique to China. The St. Lawrence Seaway, the Rhine-Main-Danube Canal, the Suez Canal, all of them produced ecological consequences that their builders never anticipated. The Pinglu Canal will too. The question is whether anyone will be paying close enough attention when those signals start arriving. But ecological uncertainty wasn't the only risk built into this project's foundation. The bet that still has to pay off. 95 million ton per year. That is the Pinglu Canal's designed cargo capacity. It is the number that justifies the $10 billion, the 28 months, the displaced families, and the unanswered ecological questions. On the day the first barge moved through, actual cargo volume was a fraction of that figure. And that gap between what a canal can carry and what it is actually carrying is the risk that no engineering achievement can eliminate on its own. Industrial supply chains do not reroute overnight. Logistics contracts are multi-year commitments. The road and rail operators who currently move Western China's cargo have relationships, infrastructure, and pricing agreements that don't dissolve the moment a new waterway opens. Shippers need to trust a route before they commit their cargo to it, and trust is built through repetition, reliability, and time. The Panama Canal took decades to approach meaningful utilization after it opened. China's own Three Gorges Reservoir shipping corridor took years to fill to its projected capacity. But here is what makes the Pinglu Canal's ramp-up different from every historical analog. When state-owned industrial enterprises in Guizhou are directed to evaluate waterway logistics as a strategic priority, evaluation moves at a different speed than it does in a purely market-driven system. Industrial park tenants being recruited to canal-side zones bring guaranteed cargo volumes with them by design. The invisible hand gets a push. Whether that push is enough to fill 95 million tons of capacity within a decade is the $10 billion question that only time can answer. And while China waits for that answer, the rest of the world is watching and asking a much bigger question of itself. The challenge to the rest of the world. Here is what the Pinglu Canal is really saying, not to China's western provinces, not to Southeast Asian trading partners, but to every nation on Earth that has spent decades accepting landlocked underdevelopment as a natural condition. It is saying that geography is not destiny. It is saying that the landlocked penalty is not permanent. And it is saying that the cost of engineering your way around it, even at $10 billion, can be entirely rational if you are willing to make the decision. Because China's western provinces are not the only productive regions on Earth being quietly strangled by distance from the coast. Look at India. The states of Jharkhand, Chhattisgarh, and Madhya Pradesh sit on some of the world's most significant reserves of coal, iron ore, and industrial minerals. They are deep inland. Their logistics costs are punishing. Their factories compete against coastal manufacturers carrying a fraction of the transport burden. India has discussed inland waterway expansion for decades. No project at Pinglu's scale or ambition has broken ground. Look at Brazil. The Cerrado and Mato Grosso regions produce agricultural and mineral volumes that rival anything Western China generates. The road dependence of Brazilian cargo logistics adds cost premiums to Brazilian exports that undercut their global competitiveness every single. The Hidrovia Paraguay-Paraná waterway system has been studied, proposed, and debated for 30 years. It remains largely undeveloped. Look at Central Africa. The Democratic Republic of Congo sits on mineral wealth of almost incomprehensible scale cobalt, coltan, copper materials that the entire global technology industry depends on. The Congo River is theoretically one of the great natural inland waterway networks on the planet. It moves almost none of that mineral wealth efficiently. The landlocked penalty there isn't an inconvenience. It is a generational trap. These are not unsolvable problems. The Pinglu Canal is proof of that. 134 miles of waterway through hostile terrain, built in 28 months, already reshaping the economic geography of a region that was losing quietly for decades. That is not a miracle. That is a decision. China looked at a map, identified a problem that had been accepted as permanent, and chose to spend $10 billion proving it wasn't. The rest of the world is still looking at its maps. The question is, who decides